Well, it gives me great pleasure to introduce our keynote speaker for day two, Dr. Michael Jackson, OBE. I can't read out all his accolades, so I've only got 55 minutes, unfortunately, so that's just not going to be possible in there. But some of the highlights is the Emeritus Professor at the University of Hull. He's also been the Dean of the, let me get this right, the Hull University Business Scheme. He's an INCOSE pioneer. He's received the Beale Medal of UK operational research. He's published over 10 books on critical systems thinking. Sorry, it's 10 books and over 150 articles on systems critical thinking. It's just a great honour to have him with us, basically. So it's, so I think we were talking last night, I think I first met you about 20 years ago at an IET event somewhere. So I'm sure that people are familiar with Michael and his work. So without further ado, Michael, I'll just hand over to you, if that's okay.
Thank you, John. Nice introduction. Can't wait to hear what I've got to say. So, good morning to everybody, and thank you to the organisers for the invitation. The invitation was strange, really. The letter came from Andrew Pemberton saying that you liked keynote speakers to be challenging. And I got the distinct impression that unless I convinced him that I was going to be challenging, I wouldn't get the gig. So I shall try my best to be challenging. In relation to the bigger picture, I'll try and relate what I'd say to the bigger picture. Embracing the new opportunities, which is the theme of this particular conference. Developing systems engineering as a brand and building towards a sustainable future. So I think what I'm going to say touches upon all those aspects. And my challenging argument is going to be that unless systems engineering makes some significant changes, then it's not going to be able to embrace the opportunities or develop its brand or engage well with the bigger picture. So that's the challenge. This is the Stuart Arnold Memorial Lecture. So I looked up, Stuart didn't know him, but I looked up Stuart Arnold, and John noted this textbook, this book that he did, Systems Engineering, very modern title actually, Systems Engineering, Coping with Complexity, a lot of books coming out with that kind of name these days. And looking at his biography, he obviously did great things for INCOSE UK, getting the name known internationally, working really hard on the standards and competencies, and actually bringing a systems approach to those standards and competencies, and seems, to be, from what you read about it, Stuart, from the stuff on the web, a really nice guy. So I wish I'd known him personally, but at least we can have a look at this quotation, which from that book, which I think is highly relevant to the theme that I'm developing. Stuart, with his co-authors, said the common sense principles of systems engineering can be applied far outside conventional engineering domains: government, legislation, welfare reform, pollution, and viruses. Quite a bit of foresight there. And it's hard to think that a systems engineering approach used to bring some sort of preparation to things prior to COVID wouldn't have enabled us to do better than actually happened. So that's all stuff, good stuff. This is the argument of the talk over the next half hour or so. Following on that quotation from Stuart's book, I'm going to argue that the bigger picture is it's a worthy ambition for systems engineering, taking on the biggest picture, seizing the opportunities. It's a worthy ambition, as Stuart Arnold indicated. But I'm going to say that it's not the first time that this kind of vision for systems engineering has been put forward. It's been put forward before and it didn't work, it failed, as I will come on to. So how do we get it right this time? There seem to be huge opportunities if we can get it right, but how to do it, what is needed, and how can it be achieved? And the approach that I've been putting forward in the books and articles that John mentioned is a critical systems thinking approach, which tries to take advantage of all the various strands of the systems movement. Systems engineers sometimes think that they know everything there is to know about systems, but so do system dynamicists, and so do many of the other strands of the systems movement. The point is that none of them has the answer, none of them offers the panacea. They need to work together, in my view, and critical systems thinking is designed to help them work together. And if they do work together, then I think there is some chance of building a systems approach, systems engineering, increasing the brand, building towards a sustainable future in either systems engineering absorbing these other messages and taking them on board, or working in cooperation with some of these other strands of the systems movement. So let me start with the worthy ambition for systems engineering. This is the Systems Engineering Vision 2035, Engineering Solutions for a Better World. A very ambitious document, I think you'd all agree. The kind of things it wants to take on, apart from the Sustainable Development Goals, are welfare, health, transportation, agriculture, a whole list of things. And stakeholder needs are defined very broadly, defined not just in terms of capability, meeting their requirements, ease of use, but in terms of sustainability and societal acceptability as well. I didn't really know how to get across the vision of SE 35, apart from going through some of its points, as I've done here, that you can see. And then something dropped into my LinkedIn box this morning, which does the job for me. So you'll forgive me if I just look at my phone to remind myself of what that was. Yeah, this does. Luned last night used a lot of Beatles song titles to illustrate her excellent talk. Bernardo de Lizardo, a Spanish systems engineer, I don't know whether some of you know him. He blogs quite frequently, and actually there's a very nice tribute from Bernardo to Stuart Arnold. Anyway, he solved my problem of how to explain the essence of systems engineering vision 2035 by going through John Lennon's, again very appropriate, in Liverpool, John Lennon's song Imagine, and comparing it line by line with the systems engineering vision 2035. So, to give you an example, taking Imagine, envisaging an ideal world, the line, imagine there's no heaven, it's easy if you try, and Bernardo says, the song encourages imagining a world without religious or ideological boundaries. And then he finds a passage from the Systems Engineering Vision 2035, which fits that great thought of John Lennon's. It's that systems engineering involves establishing goals and success criteria, envisaging a purpose and balancing stakeholder goals. And so he goes through the song, Imagine, line by line, and finds passages in SE 2035 that fit. And he concludes, and you should listen to this, he says, if you ever find yourselves feeling alone, yet harbour a belief in the power of systems engineering and an eagerness to contribute to a world improved through the systems approach, consider joining in COSY, an extraordinary community of dreamers. Well, you don't have to join, you're already part of this extraordinary community of dreamers. So congratulations, dream on. But I think, I think some changes are necessary to realise some of the ambitions that Bernardo derives from Lenin and from that particular vision. So, I think we've been down this way before. This is a couplet from Bob Dylan, actually. When you retire, you have a chance to go back to things that really inspired you in your youth, and I've been going back through Bob Dylan stuff. And once you get into Dylan, you tend to come out with his kind of couplets and language sticks in your head. Seems like we've been down this way before. Is there any truth in that, senor? It's from a song from Street Legal. And I don't have to buy you a coffee, but I would if anybody knows the song and the other lines involved. It's a great song, but we have been here before, and this was particularly the case following the Apollo program, in which, of course, systems engineering and systems management had such a great impact and was significantly responsible for the success of getting a man on the moon in 1969. And following the involvement of systems engineering in the Apollo project, there was systems engineering and its sister discipline at that time, systems analysis, became covered in moon glow, moon dust, and people started to think that it could do anything. And people sought to transfer it to other domains, certainly the US Department of Defense, and use it to try and win the Vietnam War. To other departments of the federal government to deal with urban blight and the urban problems that were significant at that stage in the States. And by 1966, 25 states and 19 cities had projects using systems engineering to deal with issues such as waste, crime, welfare, transportation, information management, urban problems, as I say. But what was the result? For the most part, it was a dismal failure, as Ida Hu's documents in her book. The main problem, and lots of other critics incidentally, Lilienfeld, Berlinski, and slightly later, Akoff, Checkland, Churchman, were all critics of this kind of approach, because it tended to try and reduce really complex problems to a single goal. So in the crime example, to get going, systems engineers had to assume a sort of the police mechanistic viewpoint of monitoring and controlling. And that leads you to try and leads you on to buying new toys for the boys, helicopters and things. So you go strictly down a narrow route instead of trying to look at the causes of crime. The Vietnam example, of course, is well known. Quantifying, going for those things that can easily be quantified. So are we winning the Vietnam War? How many body bags can we see in front of us? And humans generally treat as components in a kind of machine rather than as purposeful individuals who had distinct perspectives and viewpoints which would come into conflict. So in Hu's view, looking at systems engineering at that time and its ability to deal with complex social and organizational problems, she said the findings indicate that in their present condition they are not, and the direction in which they are developing promises little improvement. The direction in which they're developing methodologically, she mainly meant, are showing little signs of being about the improvement necessary to deal with social and organizational problems. And that, I think, has been the message just about ever since. I found a book that I've not looked up for some time by Tomlinson and Kiss. And they they were saying that the methodology is incomplete and often incorrect for this kind of issue. In particular, it tries to separate analysis and implementation. So the notion that you can somehow analyse it and then expect somebody to implement the results, not themselves having been involved. It seeks to extract hard problems from the surrounding social, organisational context. And that ain't going to work when we're all involved in that wider, bigger picture that we need to try and understand. I was absolutely delighted to get the Pioneering Award of INCOSE last year. But I did wonder why pioneer. This stuff should, this pioneer in 2022, this stuff should have been mainstream. The kind of system stuff I was talking about should have been mainstream, not pioneering. And if you look back at those who've got the Pioneer Award, people such as John Warfield, really well-established systems engineer, and then Peter Checkland, who you'll have heard of because he's had engagements with INCOSE. They were saying these things in 2007, 2008 when they got their Pioneer Awards. And I'm still saying them now. It should be mainstream, not pioneering. And the suggestion is that systems engineering has not changed enough if it still considers this stuff to be pioneering. But the opportunities are huge if we can actually get it right this time. And just some examples of some work, I think, which shows the ambition that some have for systems engineering and the opportunities available if systems engineering can meet the challenges that these people are setting for it. Cecilia Haskins, who some of you will know, edited a book on how systems engineering could move towards the sustainable development goals, how it could help to achieve the sustainable development goals. Can't have hardly have a more ambitious project to set for systems engineering, a more ambitious challenge for it. And she talks about the sort of changes of methodology that would be necessary to enable it to play a useful role in achieving the sustainable development goals. Some of you may have heard of the economist Mariana Mazzucato, who wrote a book called Mission Economy, a Moonshot Guide to Changing Capitalism. And she's written a couple of other books since then along the same theme. And she's often on news programs, Newsnight, and in the Financial Times and The Guardian and all the rest of it. And her argument in this book is that we need to learn the lessons from the Apollo program and the role of systems engineering and systems management in the Apollo program and take them forward to deal with many of the challenges that society faces today, many of the wicked problems that it faces. And she lists climate change, pollution, finance, inequality, dealing with new technologies. Her notion is that the governments and the state need to be much more ambitious and to lead and set a vision for all these things, just as a vision was set for putting a man on the moon. And then you gather together a coalition of the willing, stakeholders from private sector, public sector, third sector, incentivize and integrate them with a kind of systems engineering approach to move towards achieving this vision. This stuff has had significant impact in government. If you look at the government's document, the UK government's document on levelling up, it talks about this being led by missions. We need missions in order to achieve levelling up. I think she's probably right. I got on the train. I haven't been to Liverpool much recently, but I got on the train at Hull yesterday. It was fine, you know, TransPennine arrived, which is probably unusual. But when I got on the train and it started plodding along, I thought, my God, how long is this going to take? I've got to get back to Hull the following day fairly early on in the evening, I'm not going to be able to give this talk, because by the time this train gets onto Liverpool, I'm going to have to get back on the train to go back to Hull. Looks like taking about 8 hours each way. It actually takes 3 hours, but that's, you know, utterly disgraceful, isn't it, at this stage, and points to all the problems that there are with transportation in the north. And I thought, well, systems engineering could solve that, until I saw the queue for the drinks before the dinner last night. And I thought, well, maybe not. And then the Royal Academy of Engineering, and John Clarkson, particularly influential figure there, in Engineering Better Care, systems engineering approach to healthcare. That's a really fine document. Both Mazzucato and Clarkson again talk about what needs to change with systems engineering if it's going to fulfill its vision. We'll come on to that. I know the Royal Academy of Engineering is very influential in government circles and in policy, and I know you're trying to get into bed with them. But they still face many of the problems. The government is becoming much more interested in systems thinking and systems thinking generally. There's about 700 members of a systems thinking interest group across the various government departments now, and recently we've established a systems thinking working group between the professional body for systems thinkers in the UK, SIO, and Go Science. I'm co-chair of that. There's growing interest in government in systems thinking, and the Royal Academy is well placed to take advantage of that because of the regard with which it's held in government. But it's desperately trying to find out what systems thinking is. It actually employed somebody to do some research to try and find out what systems thinking is. So it's got a long way to go as well, I think. So what do these ambitious thinkers feel needs to be done if we're going to meet the challenges? What is needed? What is needed, in fact, to complement the kind of mechanistic approach? And I would say this about systems engineering 2035, grand ambitions, but really mechanistic documents. Not a great deal of change, again, in the thinking or in the methodology that's going to enable those things to be effectively worked towards, navigated, coped with, as Stuart Arnold puts it. Really still a mechanistic document. Well, what they're suggesting, it seems to me, is that first we need a more organismic vision to resolve the tension between control and autonomy. This is the notion that the state leads something, but then there's a coalition of the willing, and they have to have flexibility to do their thing. How do you manage this contradiction between control, making sure things are on target, while giving people involved in the process, those that you're seeking to integrate, the autonomy to get on and do their job? You need to knock away bureaucracy. You need more cross-sector communication, get rid of the silos, multidisciplinary team working, etc. Martin Reeves from the Boston Consulting Group recently said that this was getting the balance right between control and ingenuity. So control of a project, which will keep you on target, but ingenuity, you don't want to take that out. You want constant experimentation. And he compared the Apollo project to Pfizer's Lightstream project to develop a vaccine. And many of the same things can be found. Certainly kept on target, really precise goal. We want to develop this vaccine in 9 months rather than in 90 months. But a lot of freedom and autonomy in the process. They've actually had 4 factories working at one time on different formulations of the vaccine. A lot of redundancy in there. So Mazzucato puts sufficient autonomy of the parts to encourage dynamism and creativity. Now that to me is an organismic vision. We like to think we're purposeful individuals, But a lot of our parts, heart, lungs, and the rest of it, have autonomy. You don't have to think about breathing or your heart beating while, for example, you're standing here giving a lecture. The other thing that they insist upon is a more purposeful vision, by which I mean getting people with different perspectives on side. Engage stakeholders. Cecilia Haskins says, who are the key stakeholders? That's the start of her improved SE methodology that she puts forward in the Systems Engineering and SDG book. Put stakeholders first, and then all the time look at how your solution to the problems that stakeholders have fit in with the Sustainable Development Goals. Are they helping towards them, or are they not? Who are the key stakeholders? It should be the starting point, she says. Mazzucato, we need full citizen participation in defining missions, carrying them through and assessing outcomes. She asked for, she said, well, the Apollo project was really successful, but we can't replicate that, for example, in dealing with inequality, because there's all sorts of views about how you get rid of inequality. It's a much more difficult issue, complex issue in some ways. Some would say that you just need to generate wealth and let it trickle down. Others that you need some form of redistribution. But you need full citizen participation in whatever mission it is, in involvement and seeking to move towards some kinds of, if not agreement, accommodations, so that action can be taken. And Clarkson, a more holistic, flexible approach involving stakeholders. And if you look at engineering better care, lots of qualitative as well as quantitative stuff in there, stakeholder involvement from the beginning. And then you need a more societal, environmental vision. Societal Mazzucato, for example, who's disadvantaged by a particular project? We're sure that everybody's getting some benefits out of it. How can we manage to, if we're going to ask people to commit to a vision or mission, how can we make sure that the benefits are shared more equitably? Haskins, what are the system sustainability objectives and how do these link to the SDGs? Again, back to the environmental notion of what needs to be thought about and dealt with. So that's my reading of what they are saying is necessary if systems engineering is going to expand to meet these broader challenges. More organismic vision, more purposeful vision, more societal, environmental vision. And that's going to take some broader systems ideas, I think. And Stuart Arnold would have approved. He quotes in his book Peter Checkland and Peter Senge. He's open to all that kind of stuff. But how can it be achieved? What are INCOSE and INCOSE UK thinking about in terms of how it can be achieved? Well, I was talking to these are three possibilities, of which, of course, I'm going to talk in favour of the third. But these are three possibilities on the table. First of all, system science relevant to all system types. Now, that's going to solve your problem this way. If you can find a system science that is relevant to mechanical, biological, social, organisational, societal systems, then you don't really have to, that will do the job, as it were. You can transfer thinking from one domain to another, simply enough. You've got the capacity to deal with this whole set of problems if the system science is relevant beyond technical problems to broader issues. And there was the people that deal with this kind of general systems notion, that you can find general systems laws, obviously in what was once called the Society for General Systems Research, now called the International Society for Systems Sciences. And I was talking to Stephen from INCOSE last night because there was a joint working group between INCOSE and the ISSS to try and find these, have a look at whether it's possible to get these general systems laws. And I had to say to Stephen, Why are you working with these loonies? You're not going to. This has been again tried since von Bertalanffy, since Bogdanov, if you like, in 1920s, with the early days of cybernetics when it had general ambitions. You're not going to find these general systems laws. It's like waiting for Godot. You'll be waiting forever. It's not going to happen. And the reason is that emergent properties that all systems people know about, because of the organisation of elements within a system, once you reach certain levels of complexity, new things start to happen. Life, thought, intentional activity, purposeful activity in human beings, group behaviour, and so on. Organisation takes on different forms at different levels, in my view, and therefore you need different kinds of systems approach to deal with the sort of complexity you have and find at these different levels. You're not going to find general systems laws, it's lunacy. The second thing on the table, I think, is systems engineering awareness of broader issues. Now, I think it's fair to say that any decent systems engineer does this anyway, even if they're wedded to their traditional methodology, regarded as some sort of Bible for doing things. Good systems engineers will always be aware of kind of things that I've been talking about. And to me, this is the kind of thing that Haskins and Clarkson are trying to make more explicit in their rethinking of systems engineering. Let's not just have these things held by good systems engineers. Let's take them more general, for not good so good systems engineers, or in the training of systems engineers. Let's make sure they consider these broader set of issues. It's certainly one way forward, but I'm going to question it for this reason, that if you retain an essentially mechanistic perspective, then awareness of these other issues will only sort of appear in a peripheral vision, occasionally to be taken account of, occasionally to be looked at and dealt with. Maybe we can deal with them at the beginning of the project and then forget about them until get on with our normal way of proceeding. I don't think it's like that. I think that these other ways of looking at the world have to be brought forward and given equal status in people's ways of thinking, in people's minds, alongside the mechanistic approach. I don't think that increasing systems engineering awareness is enough. And there are people looking for more than that in the systems engineering literature as well. And I just picked out some examples here. There was an article by Karayanis and Forbes in 2001, incidentally, asking for a pragmatic approach, which recognises that hard problems are embedded in ongoing social processes. So you're managing and navigating, coping with those social processes, really. And the hard problems are, an element of that, but shouldn't always be to the fore. You can't just concentrate on those things. You need equally to pay attention to these other things. Silito in 2012 was saying we've got to look more closely at the intellectual foundations of systems engineering. And I certainly agree with that. And Potts et al., more recently 2020, wants systems engineers to take a closer look at systems complexity. And they're right. There's certain forms of technical complexity which systems engineering is excellent at, but there are other forms of complexity which it struggles with, and sometimes doesn't even have the beginnings of an approach for dealing with. So I argue for this critical systems thinking approach, which I'll now try and explain. It's not... So a critical systems vision for addressing the big issues, developing the systems engineering brand and building a sustainable future. I told you I'd try and take everything on in meeting Andrew's challenge. Critical systems thinking is in practice not frightening. And in some extent it draws upon things which are not new. What is new is the way of putting these things together, looking at the strengths and weaknesses of different systems approaches, and suggesting how different ways of looking at the world and different methodologies can be used in combination to address multidimensional complexity, different forms of complexity that we find either in the world or in the way we perceive the world. And it draws, as I say, upon some fairly well-known systems approaches that have been around and been developed in other communities in the systems world for quite some time. For example, Stafford Beer's viable system model. To me, that's an ideal way of thinking through how you manage the tension between control and autonomy. It's an organismic vision between control and ingenuity. It's a major issue, isn't it, in systems engineering when you think about systems of systems. But I haven't seen this model from cybernetics used anything like as much as it should be, because it's challenging. It brings an organismic rather than a mechanistic viewpoint to bear. Checkland's soft systems thinking. I'm old enough to have seen the keynote yesterday was a tribute to Philip McPherson, who established a really great Department of System Sciences at City University. Why don't we have more departments of systems sciences? Why are they all... The demand for systems thinking and systems approaches is massive. Well, universities do nothing. Sweet FA. You know, systems thinking, we're hanging on, really, the broader forms of systems thinking. I remember to have seen Philip McPherson sparring with Peter Checkland when Checkland was trying to establish his soft systems methodology. They were interesting debates. At the time, I was Checkland's pupil. I did my master's degree in systems at Lancaster University, and so I had to take his side. In retrospect, I was wrong. I think Philip McPherson actually was understood a lot of what Checkland was saying and had possibly a broader conception. But anyway, you know, this has been around for ages. But what is systems engineering trying to do with it? It doesn't see it as an equally valid way of viewing the world and of acting in the world. It tends to try and incorporate it imperialistically in the systems engineering approach, the systems engineering methodology. And then there are in systems thinking approaches such as critical systems heuristics, which embrace what I previously called the societal environmental view and ask questions about when we're doing a systems study and we draw the boundaries in particular places in order to get going and moving and taking action, we should always be reflecting upon who we're excluding, thinking about in drawing the boundaries in those ways. And critical systems heuristics allows you to do that, challenge the boundary assumptions that you're making in any systems engineering study. So that's, in my view, what we need to do. But it's a big ask for this reason, that, as I say, the Systems Engineering Vision 2035, setting out bold ambitions for SE, in terms of how to achieve them, is incredibly mechanistic in its orientation. I'm asking systems thinking and systems engineering to embrace a much wider set of worldviews, including the organismic, the purposeful, and the societal environmental, to put them on a par with the mechanistic worldview, not try and incorporate them as little bits of interest that we need to pay attention to, but put them on a par with the mechanistic view. And this requires really significant mental shifts and really flexible mental ability, huge mental ability to be able to operate with a mechanistic, organismic, purposeful and societal environmental viewpoints. But that's what critical systems thinking asks of you, a broader systems engineering that can indeed take on board these different perspectives, a multi-perspectival view regarding each of these perspectives on the world as equally legitimate. Can we inhabit them mentally? Can we look at the world mechanistically, organismically, purposeful, societal, environmental perspective? Can we use the methodologies which enable us to enact, to reflect, to do something about, to cope with the particular problems each of these visions throws up for us? I think we have methodologies available, as I've illustrated. And a multi-perspectival view, therefore, a multi-methodological view, difficult because of the mental agility involved, but I would argue absolutely essential to meet the ambitions of SE, to deal with the multidimensional complexity that is exhibited in the world. Thanks very much.
Okay, thanks very much. I've just written down universities do sweet FA. That's going to be my summary of the whole presentation. So, in fact, that was really, really good, really thought-provoking. I can see there's a number of hands up already. So I'm going to run over here. Gosh, your hand was up quick. So say who you are and who you represent.
Okay, Colin Cunningham from the University of Edinburgh. So I'm obviously one of the people that you're aiming at. What struck me looking at all your ambitions there, which I think are fantastic, is actually a lot of it chimes with what Donella Meadows was saying in the 70s. And what do you think about her work? How does that fit in with your vision?
I absolutely love Donella Meadows' work. You know, the systems thinking has been, why isn't it better known than it is? I was talking again to somebody last night about Deming's work. He was one of the first to see organisations as systems and, you know, the process diagram that we all know, instead of the functional hierarchical one. Socio-technical systems thinking played a major role in Norwegian industrial democracy project. Beer's work, some of you will know, because it's the 50th anniversary of the fall of Allende in Chile, played a significant role under the Allende government in trying to find a third way between, I guess, capitalism and communism. But Donella Meadows, of course, limits to growth. Almost at the start of the environmental movement, there was a programme on Channel 4, and it was interviewing the lady whose name I forget, who wrote the book Donut Economics. Rayworth. And she was saying, you know, Donella Meadows was her inspiration, right there at the beginning. And her book is fantastic. You know, the bestseller, I think, probably overtaken Peter Senge's book in the systems, in systems sales. A very clear exposition. She has a whole set of leverages for change, which are important at the end of that book. And the most important, she says, is the ability to move between paradigms. Don't ever hold your own paradigm dear. Cultivate the ability to move between paradigms. And that's what I'm trying to say. The only thing I would say is that she was conditioned by a system dynamics paradigm. I'm asking for, if you like, I'm trying to suggest a slightly broader view so that we're moving between systemic perspectives. The system dynamics paradigm is very, very useful. When you look at the government documents promoting systems thinking, they're often based on system dynamics. Now, why? Because it's the easiest to fit into their existing policy cycle and mechanistic way of seeing things, in my view. But yeah, absolutely on the same page. And when people talk about, you know, the founding fathers of systems thinking, who might be Bogdanov, Bertalanffy and Wiener, she was the founding mother and should be right up there in that pantheon, in my view.
Hi, David Byrne, AWE. My question's around training. We've got about 10 people here did ASEC this year, maybe 15 next year, 25 to 40 beyond that. Thinking input, process, output. Are we going to be stovepiped to ISO 15288 thinking? Do you think some years we should be, say, going with the NASA SE course or the Korean one or something completely different?
I'm not really equipped to answer that one. I don't have the knowledge to answer it. There are, of course, there are all sorts of guidelines to doing this kind of thing, ISOs, the NASA one. In COSI, of course, has its handbooks. I do keep in touch with what is being said about in the COSI handbooks. And the previous one to the one that's out now, not that long ago, looks at two ways forward for systems engineering. One of them is this founding of a general system science, which will address problems of all types. And the other is much more of a critical systems approach. Disappears a little bit from the most recent, I think, where there's much less discussion of that kind of thing. But I would be looking for some guidelines which enable people, as you'd expect me to say, to see the broader picture, the bigger picture, and to see how other systems approaches, apart from systems engineering and system dynamics, can help you not only see the world differently, but engage with it differently. That's the key thing. The reason we're powerful, I think, I think engineers are lucky. You know, the best thinkers, I wasn't an engineer, but I will think that the best thinkers that emerge from engineering and then can come and see the broader picture. So I'd be looking at guidelines that allowed you to explore different ways of conceptualizing things and different ways of intervening to change things. The one that gives you the most flexibility in that respect. Because it's necessary. You can't train people in ways which don't allow them to think about these things.
Hi, I'm Mike Wilkinson, Chief Technologist and Chief Systems Engineer at BAE Systems Submarines, also a visiting professor at Loughborough University. I was wondering, given we face a lot of really difficult existential type issues at the moment as a species, and given that if we take climate change as an example, that's a mix.
Take what as an example, sorry?
Climate change. That's a mixture of physical systems, natural systems, human, political, economic, financial systems, all of which play into that problem space. And given that none of the techniques that are currently available in politics or whatever seem to be able to address the problem on their own, how do we go about actually tackling those problems?
Yeah, it's a really good question. Because, of course, our ambition was in systems thinking and systems engineering to be able to tackle the problem as a whole. That was in many ways the rationale for establishing systems as a discipline. Systems engineering, let's look at the whole and make sure all the parts fit into the achievement of the whole. Let's integrate them in systems of systems to achieve the whole. There's a distinction which I like, which is one by a French systems person, Edgar Morin, and he talks about two different ways of addressing complexity. And he says there's a restricted complexity approach, which still believes that you can capture what's important about the whole system and learn about how to intervene in the whole system. And that doesn't go much beyond traditional science, and it's good. You know, you learn good modelling techniques. Nobody's knocking any of this stuff. You use good modelling techniques. Interdisciplinary, multidisciplinary work can help. But he says, what you actually need is a general complexity approach, and that means the thing that you're seeking to understand is effectively so complex that it's unknowable. And I've moved much more, and I see this in my own thinking, much more from the idea that we can capture the system and somehow model it and learn about how to act in it in a productive, efficient way, to thinking, well, that's unknowable. Let me use different approaches, different methodologies in a trial and error way to see which bring about improvements and constantly learn from that process. So a move from a scientific perspective, on which I think critical system thinking was guilty of initially, to a much more pragmatic perspective. I think the background to all our work should be pragmatism. These things are too complex, but we can learn about them and gradually try and find ways of improving them.
So we've got a question coming through on Slido. What's your view on Theory U and Otto Scharmer and his colleagues at MIT?
Of who?
Otto Scharmer and his colleagues at MIT.
Theory, yeah, I know it, but you're going to have to remind me what it is.
Does whoever put this question forward want to...
Hi. Yeah, no, there's something hi, Graham Fawley from PA Consulting. It's actually something one of my system engineer clients introduced to me, because he does lots of reading. And it seemed to be addressing a lot of the themes that you were talking about. So I understand, from having read a slim volume, which is a short version of a very big book apparently, there is a group at MIT that's looking at some of these really big societal issues like, global warming and the collapse of capitalism and so on and so forth. And he comes up with a sort of a blend of systems thinking and mindfulness and a bunch of other stuff. But it's in that camp anyway. But
well, look, I can answer now already. The MIT group is one group which is world-renowned and established itself, and I think the work of John Sterman, for example, is fantastic. And system dynamics models are great. He was in the right place, the right times, right places, in a participative manner. People like Otto Scharmer and Peter Senge have gone off in this sort of journey of trying to combine self-awareness and mindfulness. Look, to me, I'm from Yorkshire. It's self-indulgent twaddle. Okay.
Right, I think that's the absolutely perfect note to end on. So we got academics do FA, absolute twaddle. They're the two main takeaways. I think that's going to be the theme for next year's conference. So, Michael, that was absolutely brilliant. Thanks so much. Can we please show our appreciation to Michael?